go. All right. So the multiplicative inverse, also known as the reciprocal, all right, so what the multiplicative inverse does, if you took a term, so some term with variables in it, and you multiplied it by its multiplicative inverse, which is written like this, the term to the -1 power, that means the multiplicative inverse right here. What that does is that gives you 1. So, for example, if I had a term five, well, its inverse would be 1/5. Because when you multiply those, you get 1. Okay, if you had 5x, multiplicative inverse would be 1/5x. Because when you multiply those, you get 1. If you had like 2/3, its multiplicative inverse would be 3/2. It's reciprocal, because when you multiply those, you get 1. So then it comes down to, well, what would you, if you had an imaginary number, what would be its multiplicative inverse? Okay, so let's say you had like 2i. All right, so when we get the multiplicative inverse, that's these guys right here, and we multiply the original by their inverse, we always get 1. So now you're trying to figure out, well, what would this have to be so that when you took 2i times whatever we figure out this is, we're going to end up with 1. Any ideas? What would I put here so that when I multiply it by 2i, it becomes 1? The product is 1. 1 over 2i? Okay, so let's try that. So we're going to try 1 over 2i. So I got 2i times 1 over 2i. So if I rewrote this, that would be the same. This would be 2 times I times 1/2 times 1 over I. Because remember, we can't have a negative in the, you can't have I in the denominator. Okay, would that equal 1? So these would cancel, but you'd end up with -1, because that's going to be I squared, and that's -1.
So it would be -1 over 2.
-1/2 I. Okay. So if this reciprocal right here, that's the same as 1 over 2 times 1 over I. Okay, which is 1/2. And this would be negative I. And that's where you get negative 1/2 I. Are we okay with that? Okay. So that would be our multiplicative inverse would be negative 1/2 I. Okay, let's try let's see. Okay, the multiplicative inverse of I. Negative I? Okay, let's see if that works. All right, so if I go negative I, that would equal negative I squared, which would be the opposite of negative 1, which is 1. Yep. Okay, how about 4I? Negative 1/4 I. Negative, it's going to be just like what you did for 2. Negative 1/4 I. Whoops, this was 4I. Okay, then what if we combine these things? 3 plus 4I. Well, actually, let's do it like this. Let's do A plus BI. And this is what we did the other day. Okay, so when we did this on the assignment, let me go back, let me find that. Let's see, was it here? Nope. That's division. It was these 2 pages right here. So it was this work right here that we did for number 7. Okay, what did you guys come up with? Remember, what was our solution for number 7? Yeah.
It's A minus BI divided by A squared plus B squared.
Right. That was when we did all of this work the other day, last week, we came up with this. So if you've got a vector, this is equal to its multiplicative inverse. And we're not going to go through the derivation of it again, but that's what we came up with when we did all the work last week. All right, so the multiplicative inverse here is going to be A minus BI. So that just means the opposite of whatever B is, all divided by A squared plus B squared. See, when you multiply if you did the multiplication for these, if I did this, A squared plus B squared times A minus BI over, where am I? Oops. This is just A plus BI times A squared plus B squared. If you multiplied those out, the denominator would be A squared plus B squared. If you multiplied out the numerator, you got A plus BI, A minus BI. You get A squared, negative ABI, positive ABI, and negative B squared I squared. And that ends up becoming A squared plus B squared. So when you multiply those two, you get that. So that's equal to 1. When you multiply out the two numerators. All right? So this is your conjugate. Shh. Just pick it up and get rid of it. Here we go. That's your multiplicative inverse. All right, so the multiplicative inverse of, if I had, let's say, 4 plus 3i and 7 minus 2i, okay, we want to know what's the multiplicative inverse. All right, so now, okay, are we over the beetle? Oh, jeez. Alrighty, I'm moving on. Here we go. So this would be 4 minus 3i over 4 squared plus 3 squared. So the multiplicative inverse altogether would be this. Okay, for this one, it's going to be 7. The opposite of 2i, negative 2i, is 2i all over 7 squared plus negative 2 squared. So 7i plus 49 plus 4 is 53. And that's how you get the multiplicative inverse. Okay, now the reason you need that is so that you can divide. Multiplying by the multiplicative inverse is the same as dividing. That's the big idea here. All right? So, multiplying by a term's multiplicative inverse is the same as dividing. Is the same as dividing. So now we have a way of dividing complex numbers. So now you can do all the operations. You can add, you can subtract, you can multiply, and now you can divide. Okay, so the multiplicative inverse of a complex number, a plus bi, its inverse so if I had some number, I guess, we don't need that, f of x. Let's say I had some vector v. The inverse of v would be a minus bi over a squared plus b squared. That's your multiplicative inverse. Okay? Any questions up to this? It's pretty straightforward because we did all the legwork the other day. Okay, now the other part is the idea of the conjugate. Okay, so the conjugate, so we've done this, we found the multiplicative inverse, okay, and now the conjugate, okay, conjugate of a complex number. Okay, the conjugate takes a complex number and it turns it into a real number. Okay. So what this does is it transforms a complex number into a real number. See, and you can see what the complex, you can already see what the conjugate is. That was the numerator of this term here. Because when I take, if you look up here, guys, when I take this numerator and I multiply it by that numerator, it becomes a real number. See, there's no I in it anymore. So this numerator right here is known as the conjugate. So it eliminates the I. All right, so if you have a term, A plus BI, okay, its conjugate is A minus BI. And if you had a term A minus BI, its conjugate is going to be A plus BI. Okay, all right, guys. So open up to get out your packets. Um, Okay, and what your assignment is on here, guys, is on, and we'll just do this on a sheet of paper. You don't have to do it digitally. So, on whatever you're doing it on, let's see. How did we do this? Can't remember. Problem set format. Okay, so you're going to put on a sheet of paper. Control C. So this is going to be, copy this. So copy. Add a page. Paste. Okay. And this is lesson 7. Problem set. Okay, and you're gonna do set. So this is lesson 7, problem sets 1 through 3. Home 18. So that goes there, and then over here, your name, period, date, all that good stuff. Okay, so what you're doing on here, you got 1, A and B, A, B. Okay, so you want to do your multiplicative inverse of negative 5i. Okay, and we know our formula for inverses is A minus BI divided by A squared plus B squared. So if I did number 1 here, negative 5i. Well, if we use this general rule right here, okay, 5i would be the same as 0 minus 5i. Okay, so then what's our conjugate going to be? What's the numerator?
0 squared plus 5i.
The numerator 0 plus 5i. Do you see why? You understand why that is?
Yeah, it's negative.
Yeah, it's the opposite. Yeah, minus b is the opposite. Okay, and then down here, 0 squared plus 5 squared. So I got 5i over 25, which is I over 5. Okay, so that was A. Now do B. Okay. 5 take away root 3i. Okay. So what's our conjugate going to be? Numerator. Go ahead.
5 what? Square root 3i.
Okay, denominator.
3 plus 25.
Yep, 5 squared plus root 3 squared. I over 28. Okay, and then part 2, you just have all these different ones that you're doing conjugates for. A, B, C. Let's take a look at C. Root 3 minus I over 4. Now, this, guys, would be the same as the square root of 3 over 4 minus 1/4 I. So now you have your A value and your B value. That's A, and that's B. Okay, so what do you think that would end up looking like? What would be the conjugate?
3 plus 1 over 4 over. Wait, square root with the square root of 3 plus 1 over 4. I think would be the top.
Okay, so you could write it separate like that if you wanted to. Okay, so this would be, or I can just leave it like that, plus 1/4 I. Okay. Now root 3 over 4 squared plus 1/4 squared. Now we just got to simplify that. So you'd have 3/16 plus 1/16. So you got 4/16. And that's really just 1/4. All right, and now how do you simplify that? You got fractions in the top and fractions in the bottom. This means divide by 1/4. Well,
Maybe cross cancel.
that would be the same as multiplying by 4 over 1, right? So what this becomes, the top of this times 4 over 1. Okay, dividing by 1/4, same as multiplying by 4 over 1. And then I can just distribute. So I end up with root 3, because the 4's cancel, plus I. And there's your inverse. Okay, let's do one more here. How about I cubed? The first one. Okay, now remember when you went around the circle, what did I cube land on? What's it the same as? Yeah, I cubed end up, because this is I, this is I squared right here, and that's I cubed. So I cubed is the same as negative I. Any questions on why that is, folks? So doing this is, I could just rewrite this as negative I. So that's the same as 0 minus I. There's A. A is 0 and B is 1. And now you can write out your conjugate, your multiplicative inverse, I mean. So this would be 0 plus I, or just plain old I, and here I'd have 0 squared plus negative 1 squared which would be I over 1, which is just I. So the multiplicative inverse of I to the third is actually I. When you multiply those, you get 1. Okay, so if I took those two and I multiplied them, guys, I get 1. See, watch. If I go I cubed times I, that's I to the fourth, and I to the fourth is 1. So that's the multiplicative inverse of I cubed. All right, so you finished that up. You got 1, 2, and then number 3. And that'll be due on Wednesday. Okay, so